Welcome. My name is Bart. Most of you will know me. Some are new faces to me, but perhaps by name. I will check later. Welcome to this Fairway presentation. The idea was to have some kind of interactivity, which I will try and make happen, but particularly after a break. So I will first do a presentation. You will see a lot of graphics on screen, a lot of examples, and things may be too quick. No matter, feel free to interrupt. I will cut you off when I think it will take too much time. And we have plenty of time to discuss things afterwards, and you can always call me when back at the office. So yeah, raise your questions, raise your finger, I don't know, we'll see how things go. Fairway training, so the first part is more of a, well, showcase. I should be able to do this. Yeah, there we go. Why Fairway? This is the content. So the left side would be before a short break, and the right side would be after a short break. So my I have, what do I have? 49 slides and 3/4 to do it. So some slides contain more graphics. So I will talk quickly. Why Fairway? Well, typically line fairing and drafting a lines plan was done manually with ducks and a spline. These weights are called ducks, olifantjes in Dutch, and that's physical. You can actually see what you're doing, and the shape you are drafting is of the actual hull, not something outside of your actual hull, like in NURB surfaces. I will not go into detail on NURB surfaces, but well, this is one of the core reasons that Herbert has invented Fairway in the past. Well, what does that mean? As in physical splines, you have direct control, basically over everything. So we, if I zoom in here, let's see if that works as I would expect. Ooh, there. You can just enter any coordinate for any point on the spline, and the spline will follow. And that's much, well, if you have a physical spline embedding, you move things, put the weight down, which is the point in this case, and then you'd have a different shape. Tangents are the next slide, and here we can make a, I don't know if it's legible from behind. Oh, you don't see my cursor, of course. Laser pointer. Yeah, but oh, there. Well, okay. Laser pointer. Thank you. Here you can see a slave tangent, which means that this side of, oh, now it's, can I just hide it then? I should have one setting for the rest of the demonstration. Okay. This is the master, and that is a slave tangent, so it will be fed into the flat bottom there. That's something you want to have direct control over. Another thing is the line type, which is there. In this case, we use a general spline, and that comes with a number of properties, which I will go into a bit later. But we can also define a straight line, a circular arc, or a conical. So we have a library of basic line types for modeling. And you have, as I said in the previous slide, direct control over that. Then, this allows a toolbox approach. Or these ideas do not allow, they require a toolbox approach, because much like manual drafting, you never know what you're going to do next. You run into a problem, you go on and solve that, or you want to define something further than you have, and well, you want to be able to do basically anything at any point in time. So that's why we have a toolbox. I will not discuss all these different features now, but that's the general idea. Direct control, how do you say, not abstract entities, but just lines in the surface with direct control and a toolbox to make it work. Okay. Then, I have drawn up, drafted a few scenarios of what we use Fairway for, or what you could use Fairway for. And of course you have your ideas, and it's not only new designs, which I will give a short demo of after the short break, but this is the first scenario that I have. First, I have selected the model. Well, that's the easy part, but I want to scale it. So these are some of the main dimensions and allow scaling factors, and if I click on, oh, you can read it like this. So these are the original ones, and I will scale it to these length, height, width. Well, then you'll see a preview on what will happen. The vessel will be larger, And if you think, well, that's about okay, you press apply, and then you have a new shape. So that's straightforward scaling, nothing particular about that. But now we want to, well, we did not only want to scale it, I want to generate a bulbous bow. We have something called point-based spatial deformation. So from a point, you give a vector in which direction you should blow up or shrink the coordinates of the surroundings with reference to this point. That's a bit of a trick to figure it out. We will expand on that later on. There are ideas on that, on how to create a more intuitive tool for that. This costs a bit of time, but if you master it, it's rather quick, because if you press apply, you have the startings of a bulbous bow. I didn't work it out completely, it's just a showcase. But then Herbert has already shown the lean NURBS. You want to do something with it, so you export this to some or other output file. I chose NURBS in this case. We could have done a NURBS surface, actually. We could have written STL file or something else, but anyway. And this is what you get. I've only bothered with the bow section, the modified part here, if you like. And the nice thing is that with this export of lean NURBS, it's watertight, so there are no gaps between the different patches of the surface that I defined. That's scenario one. Make a scale and make a change and, well, continue from there. That is when you start with a fairway hull. You don't always have that. Sometimes you have a historic database. There is some lines plan. Somebody took great effort in digitizing that in Pius. Yeah, I'm watching the time, because doing this live is always different, of course. Well, what do? You open a Pius model in Fairway. This is the Pius model, 3D or photographic projection of it, as you see in HullDev. And that would translate to this Fairway model, which is not complete. We missed the flat bottom, we missed the flat sideline, every chine is missing. So that's what we do next. This line was already added, and here we go about connecting the dots, really. You can switch on the knuckle points, so you have good candidates for the next point. I cannot connect this point to somewhere there, because it needs to run over the curves that are in the model, because they are on the hull. There needs to be an intersection with the next curve on the hull. But it's, well, too many frames for this, actually. I should have thought of that earlier, but then again, clicking these points, it will set you back 60 seconds or so, and then you have the complete model with all the frames. So why not? If you have done that, it was already a valid Fairway model when you imported it from Pius. So if you're done with all these bits and pieces, then you should end up with something like this. And this is not completely fair, because I've hidden some of the water lines and so on, so you only see the rendered surface and the lines I want you to see. But for rendering, this would look ugly if you don't insert a number of water lines, because the patches in between the frames are poorly defined. So I'm cheating a bit, but okay, it's a demo. Then you make the required changes. If we go back one, here you see a slanted deck, and the next one has a curved deck. So I will not make things more difficult than they need to be. I just modified the deck here a little, but for your info, this area was defined as a single surface of the hull. So I marked out that part of the hull, and I made it a slave surface. That means I changed this frame to a circular arc, and then the rest will follow. Oh, you don't see my... Yeah, okay. This patch there, woohoo. This frame was defined as a circular arc, and the rest will follow. That's why we call it a slave surface. So all the identical type lines in the same surface will follow the master of that one. Then I wasn't done. There was a parallel midship, which I cut out there. That's a separate option. It's not scaling. It's really throwing away everything from a certain length to another certain length. So if you don't have a parallel midship to start with, you end up with something ugly, because it will not match fore and aft ship. So beware of that. You can throw away any piece of the vessel there, but it would help if that would lead to something sensible, of course. Well, you'd end up with this, and you can just send that back to Fairway, and here we have the shortened to Pius, and here we have well, the same frames but shorter and with a circular deck. That's another scenario that we, well, use quite a bit actually to, because many sister vessels are built, oh, we have this model, but it's now lengthened, and rather than doing that in the hull dev module of Pius, we do that in Fairway. The split hopper.
Does it make any difference, the heat file or FWI file?
Yeah, it's the Fairway has its own data structure, which is, there is much more information in the Fairway model than in the heat file. Heat file are only cross sections, so we can import heat files and we can export them from Fairway, but in Fairway we typically have much more information, much more curves. We can render a Fairway model, that is the surface, and if we render a Pius model, it will only be cross sections with a bit of color on that cross section, but not in between. So yeah, it's quite different actually. But you can readily export the heat file from Fairway. If you have Fairway, you have that as well. That's the first and free export option.
Are there other methods for target lines to import?
Yes, I will discuss that later on. We have different well, tools for that as well. So a split hopper. Actually, this is not a split hopper yet. I took a model and I've hidden all the curves in here. I only show you the surface. And the waterlines, frames, and buttocks you see here are projected onto the model. So if you have a few curves, you can always show that. But that's not what I wanted to show here. What I want to show is a different transformation, namely a rotation. This is the height, so this is where the hinges are for the split hopper. And this is the direction, so in longitudinal direction, and minus 22 degrees. If you press apply. I need to work on that. This is direction, and this is the height of the hinge at center line. And if we press apply there, you'd have this. And of course, there will be a start and an end to each frame, and you must make sure that they start and end at the same position, because the hull dev will automatically fill in the gap between center line and this model, but it needs to go around and back again. So, well, you will notice if you just try it, nothing much can happen, nothing much can go wrong. The only risk you have is that you should do it again. But if you try that twice or thrice, then you will succeed in sending back such a model. And this is actually, we need to do these calculations. It's a bit rubbish because for stability, well, it's an empty catamaran if you make it like this, and it will always comply. But for longitudinal strength, I believe that at Bureau Veritas, they do some calculations to study the strength of the hinges for this. So that's why we need to go through the motions of a complete stability calculation for that. Okay. This is, well, what we sent back, and I'm not sure if it's visible here. Let's see if we can zoom in a little. You see here that the frames will start at centerline, go out, go around the hull, and go back to centerline again, and up to the highest point of the frame. Yeah, from here and all the way back there. So there needs to be a start and end of the frame should be here, but they must not be connected. Otherwise you have an enclosed frame that will not work in Pius. So they should have the same position, but they should not close the, they should not be connected at that point. Okay. Then another one, only a recent question from a client. He said, I have a barge, not this one. This is actually the demo Morgenstond, for which we have done local Pius as a demo version. And this is the model you saw earlier of the frigate. But they want to put up a number of vessels with an oblique center line. So it's not straightforward. These ships, they are slightly oblique. And, well, you cannot do that in Fairway, not with the regular frames, because the frames are really cross-section. So if you move the vessel, you need to have, well, not frames, but how do you say, oblique curves. Well, that's what we did. That's what I did in Fairway, just for the demo. So here we have it. This was the original model. I've scaled it down and rotated a bit. You can see here that I've closed the deck for this one because of the same reason. I need to have the same start and end point for each frame. Otherwise it will not work in Pius. And this is, well, after rotation you can interpolate the frames. And here it goes down on the, well, the deck edge there. It will go straight down. And this is of course not a nice model. Typically in Pius, you would require double frames there. Egbert.
You double the ship.
I doubled the ship first.
You have only a port side hill or starboard hill.
I doubled the ship first, that's correct. I read a double file into Pius. We have some tools to double model, so if you use port side and starboard, you could do it actually with, it's actually easier to do it in two separate models, port side and starboard separately. You only need to reverse the frame direction and so on. You do two sides of one model, one port side, one starboard. You need to do everything twice, but it's easier. I chose to do this all in one go with a double hull. It's also nicer for presentation. So I wish you hadn't brought that up. But anyway, normally in Pius you would have a double frame here and there to mark the discontinuity in the sectional area curve. But in this case, well, by the time this will contribute to stability, you have bigger issues. So then with a minimal hull, I enjoyed doing this one actually. Yeah, I have a counter here, so I'm checking, but thank you, keep that in mind. Yeah, we need to start with something, so I called it demo developable because I thought, well, I want to do something different, something I haven't shown before, and we upgraded the features for this a little bit. Not much, but we improved things here and there, and we will do that again. Fairway uses a solid model. We have nothing, so I could build up a solid model from nothing, but it will allow you, Fairway will allow you to start with something. You just define, well, a name, that's not even obligatory, but some main dimensions. These are, well, target values, but if you don't use them, never mind. We can check these values later on for the actual model, but I'm not interested in them right now. This is what you get. This is the minimal hull with one frame here in blue, one center line, and one deck line. And I start building from there. So what do? This is striped rendering, actually, much like zebra striping in Rhino that most people know, but then it shows at least that we have some shape. I included this transom. It's a curve in a plane, so that's why it's purple, to distinguish it from the 3D deck line. And I made a knuckle there for the bow, and this is still my only frame. Okay. Then I added a few, well, oblique, it's not even water lines, but oblique planes. I just picked the knuckle here and this knuckle there and stacked a few on top of each other with a distance of 0.5 meters. And the third point here, I just visually checked whether or not I was happy with the, well, let's say the sideways, the heel of these planes. They are oblique in all directions actually, but it's still planes. And you can interpolate, well, a bunch of them in one go. This is what you get after interpolating some further frames. And these patches are rendered, let's say, from the outside inward. That's how we define our surfaces in Fairway. And of course, this is a chine, so you will have a discontinuity here, because the frames here would have a little chine there. Not this one, because they were interpolated. Actually, they are hollow here. So, but the knuckles are not included there yet, because I switched them on as chines later on. Doesn't matter. I fixed all that. Then I defined the plates, and that's just a simple matter of you select the shell feature and then define the region, and then you pick out 4 points on the hull, which together, or 4 points in this case, can be different. If you're making plate expansions, it can be a wildly, how do you say, complex contour, and the selected contour will highlight if it's closed. Then you're done, and you will do some settings to make it a surface. It's not really sharp there. Can I zoom in here a little? There. It's a surface, and we need to do some setting. The last thing I changed was the color to make it pop out a little. There. This was the last one. Define shell regions, that's what I've done. And then I can just pull on these curves. And because I set the shell plates to be developable along 2 chine. So this is one defining chine, and this is the second defining chine for that one. You will see here well, these are the frames, but little curves in between there. These are the rulings, so those are the bending lines for the plate. That's what makes them developable. The trick is that along these rulings, this curve and that curve would be in the same plane. So you can roll it over the table. The entire process was new to me. I hadn't done this before, and it was done in 20 minutes. So that's so if I do this again, it will be done, I don't know, within a quarter of an hour or so. It's pretty quick and developable.
This developable plate option, but can you also integrate it in an existing hull if you want to make the shell shape behind the bow thruster?
Yeah, it will change, of course. If it wasn't developable, you cannot have a double curved plate and make it developable, because then it will no longer be double curved.
No, that I understand, but if you have the bow thruster pipe,
yeah,
and I'm looking aft, and you have your water line running like this, then it could be that you make a scallop behind it, which is developable.
Yes, you can. Actually, there are some features for that. You can either project the curve from a point. So if you find a circular point at the pipe and project it onto the hull and connect the curves that you have, you will have a developable scallop plate. Or there are many ways to go about it. But to general shapes here, as long as they are parallel along the route, maybe on different places, then you'd have a developable plate within two chines. But we have more developable plate types. One is in one direction, so a example center line and an inclined frame. If the angles are identical everywhere, then the plate is developable. Or if it's completely flat, or a cone would also be developable. So you can use those shapes. I'd have chosen the most flexible one. But yeah, you can do that. And then, well, this is printing the model actually. We have a 3D printer at home at the office. And this is the model, actually this one. And the trick is, of course, developable. If you look here and you see this curve parallel to that ship, then you look alongside one of the rulings. And this is actually a nice model because it's a bit shorter than typical coasters. The proportions are better to have something in your hand, of course. I will be printing a pair of shoes next. And also I need to include it here because this presentation will be put on the internet and people will not see the model as you have. Okay. Then, hydrostatics and transformation, new subject. These are not the design examples that I had, but just on the features that we have in Pius, in Fairway. Okay. We can work with hydrostatics. One back. And all the way, this is on rather than back. Hydrostatics, you click on there, and it will give a warning down below here it's hardly legible, on the actual sectional area curve there. The hydrostatics are calculated in Pius as in Fairway based on the sectional area curve, which looks like this. If it looks like this, it's pretty much okay. If you have some low point here, then you have a partial frame, a frame that does not extend up to deckline or beyond, and that will have a very small area, so you will have your regular sectional area curve, one frame down below, and then the rest. So you'll get a loop in your sectional area curve. If it looks like this, then the hydrostatics are good. Hydrostatics are listed here, draft for this draft, and some data on there on what you have just built. Okay, then we can play tricks with that, but for that you need to switch the tricks on. So here, under the save and then the options that we have, it should not be on the icon, is a little different, but on the settings there you can select preferences. And preferences allow you to switch this on if you have the option design using a target sectional area curve. It's a bit advanced and it's a bit outdated. So it's complex to model everything behind it, and it's also hardly used anymore, except, as I'm told, at the TU Delft, where they still design a sectional area curve first and then draw up the lines plan. That has been the case at least for 20 years that I worked at SARC. I don't know if they still do that, but that was thought of because the calculations were expensive and took a long time. So the sectional area curve, yeah, if you use that, you come to a design, but we don't need that anymore because I have the hydrostatics readily available with the push of a button. So I can, well, I have better guidance doing this manually than with the actual sectional area curve. However, we need it as well for some other features there. We can create a target sectional area curve. And if I do that, this is what happens. We get a second one. I've displaced it a little bit. You can see the original one in black and the other one I'm changing. So I have a target sectional area curve for whatever purpose I want, and I will show you one of the purposes in a moment. And this is just a list of coordinates on the length, and I can drag these points to shape my sectional area curve. It's not a spline. Yeah, it is under the surface, but we do not allow you to use that. You can just delete or add these points here. If you have 2 points, you delete a number of them. Or if you have, I don't know, if you want to make a barge, then your sectional area curve is rather straightforward. But if you have that, we can do Leckenby frame shifting. So we transform, it says here, Leckenby frame shifting. You redesign your sectional area curve, and the frames will shift it to the new place in the new sectional area curve to meet the design sectional area curve, the position for that frame. So here I defined -3 for the -3% difference in longitudinal center of buoyancy to midship. It was -1.4, and you can see here that, well, the change here. You see frames are shifted aft. You would expect that because the buoyancy needs to be shifted aft, so you get a more slender forebody and a more full aft body. But the old position is listed in blue, and the new selected one is displayed in yellow. And after you press apply, there we go. This is the oh yeah, I could zoom in here. There's the -3 bit. This is the original value. That is the -3%. If I press apply, then here it will follow up on that and, well, come pretty close because we need to recalculate the sectional area curve. It's a bit different than the old one, but this would be sufficient accuracy for anyone, I assume. That, and as a bonus, this is actually how they did it in the past. The blue area here represents the surface for this frame on the target sectional area curve. So these points designate, show this point, this length. You see we have too little. Sorry. These two markers show which point we should have. The blue area would be the area of the frame up to this waterline, which is the design waterline at 8 meters. And you can see that this area is far larger than that area, so we have, a deficit in area on this frame. The frame needs to be larger to have this area. And that also shows here we have a deficit of some 6 cubic meters, and you can change the frame. Now, this is not what they call an affine transformation. So if you do this frame by frame, the rest of your model will look spitting ugly, of course, because you only did this on the frames and not on the waterlines and not on the buttocks in between. So you do this if you start designing with frames. If you have that, then you can fill in the waterlines and whatever. Otherwise, you'd end up with a nightmare of entangled waterlines and buttocks and what have you. But anyway, we have it, and we are asked if we have it, and if they have Fairway and this option, they don't use it because you have the hydrostatics readily available. You don't need to bother with the sectional area curve when you get started. Typically, you don't, at least. You may, but you don't. Plate expansions. I've taken some hull. This is actually a parent hull in Fairway. I should speed up a little. We define a shell region again. This is actually a triangular plate, or well, double curve, but still triangle. The boundaries are triangular. We create a plate expansion for that. That's just the push of a button. If we have defined the plate correctly and the hull is fair and sufficiently divided with waterlines and frames, sufficient support, then we have a plate expansion. Egbert knows that The practice is sometimes more difficult than that, but this is the theory, and it all works. It works, but sometimes with really difficult plates and really complex shapes, you have a bit of work to get it done, but not in this case. So we have the plate expansion can be sent to DXF, and these are the plate molds for the people on the press to judge if the plates are okay. You put them in a row. There is a little notch there. These are aligned and put in the right angle. This is for orientation. This little. These notches should be aligned, and this will show that the plates are all facing the same direction. You know, otherwise, it would be very easy to make a mistake and have one of these molds reverse. Templates, I should say. It's not a mold. But you can also switch on, well, there, properties of curve, and then say toggle seams or toggle butts. These are the butts, these are the seams, and if you do that, and then click generate plates, then miraculously we have divided the entire surface in defined plates. And this is really a 10-second job. So selecting your butts and seams, you need to have curves there, of course. So you need to define some curves. But then this is, well, easy peasy. I skipped, this will be a plate as well, but it's a solid keel, so I removed that from the list. And then, well, this is something you can generate with Fairway, a 3D view on the plate layout. And we have the plate.
Plate thickness is included in this part.
Yes, you can define the plate thickness, and the actual plate expansion will be done at half the plate's thickness to ensure there's a neutral line of your plate. Yeah.
And so Fairway also can give you a center of gravity?
Yes.
Of this?
Yes.
Okay.
And the weight of the plates. Yeah, in tables, the yield of the plate, so the stretching or shrinkage. If you choose, these are different optimization algorithms. We can do without shrinkage. We can do no deformation at the sides, so no stretching or shrinkage on the sides, or minimal energy. So that would include both stretching and shrinkage. But typically on Northwest European yards, we only use stretching of plates.
Yeah.
We don't heat the plates up. Okay.
Okay, thanks.
Plate expansions, and only the curves in your model will be displayed there, or not if you choose not to. Okay, so that concludes the bit on plate expansions. Then, to come back to an earlier question, can you import other things? Yeah, well, can Fairway read any of this? This comes from the Rhino manual. As you see, Rhino comes first. Yeah, we can only read the highlighted ones, and even then depending on contents, because these are both open formats, and you can put in any kind of stuff. I will show a bit on that later, but typically most of these models can be converted to a DXF or an IGES file, so we don't need to read it to read every type of file, because Rhino is so readily available, or other programs that will do conversion for us. And rather than implementing all these different file formats basically containing the same info, we chose to, well, do a limited subset of that. Why only IGES and DXF? Well, I just explained that. They are mostly used, and you can basically convert anything into them. Why is it not straightforward? Well, I will show you after the break that the entire data structure of Fairway is more complex, and we claim superior than the lack of data structure in other programs, because typically you would have a set of services that only mean something in the context of that program. It's easy to move out one service and you have a gap in your model. In Fairway you cannot do that. There are no gaps in the Fairway model. There can be inconsistencies of other types, but we work with the curves on the service, and the gaps are filled with some service. So we have basically reversed all of that. As I shown at the beginning, the physical spline and batten, the curves are king in Fairway, not the rest. So it's an entirely different setup of the data. We can only define every curve once. Yeah, you can run multiple curves along the same points, but it would cause you some headaches to untangle that afterwards. Egbert knows. This sometimes happens, and don't go there, because you don't need multiple curves over. It's the same curve, so you should only define it once. Otherwise, it will be ambiguous. And that's not a problem in most other, in Rhino, you can have the same service 3 times on the same location. Yeah, nobody cares. Except if you want to convert it to pies, of course, to Fairway. And we manipulate the curves, and the gaps between the curves will be filled automatically by Fairway without user interference. So we only manipulate the stuff that we are interested in, because basically everything in between, yeah, that will follow. If you do your work nicely, you will end up with a nice, smooth, fair service. There is a lot more on that. It's explained in the manual, and I've included the link to the online version of that. Yeehaw, there you go. As in Fairway, it's context sensitive, so don't be shy to read that every once in a while. Dig in, and it will be rewarding because you will be able to do more if you understand what the software is all about. Then, conversion must typically create a solid from a wireframe. So even if we start with surfaces, we deconstruct the surfaces into a wireframe, and then recombine that into a solid after that. And the assumption is that we are not interested in deck and centerline, so we skip that part of the surface, but it's present in Fairway. I can switch it on any moment. So we use a solid, even if we're not interested in the full enclosed set of surfaces. But this last one, if that were easy, if you can convert a solid from a wireframe, then any CAD software could render a square or a cube, for instance. And not without any further interference. And we do this conversion semi-automatically. There may be some user input there, depending on the quality of the model, basically.
8 minutes.
8 minutes. I'm at 36 or 40. Okay, I will speed up. I will snoop a bit of the demos later on. Thank you. Importing models. So we have an issue here because there are gaps in the model. This in Rhino means that we have a naked edge, and a naked edge means an edge without a matching counterpart. You cannot have that in a solid model, so that's one. Still, I'm going to import it with some settings. Merge succeeding curves, no. Preference of mine, but figure that out later. Check the manual. This curve, these are the offending ones that you saw in the model earlier. Those cause the problem. So what I do, I simply delete them. And this is not a solid model yet. This is only a bunch of curves imported in Fairway. Then I will connect these dots. I ended here. I need to follow up on there and include the frame.
You need to do your pointer thing.
Yeah, sorry, I will go back. Yeah, we will take a few minutes of the demo. Here, I ended up here, and the rest of this curve should be there, and this frame is also not included yet. So this is halfway through connecting the dots. Then, import of models. Yeah, I need to generate the connections, and you can see here all these blue markers. Every curve is checked against every other curve to see if they match within this tolerance of 1 millimeter. In this case, 1 millimeter. Okay, then I continue, and we have an issue here because, well, I have picked the wrong point there, 2 points quite close to each other, and I missed this one, so this curve doesn't end up on its neighbor there. There's a gap. This is a free hanging end of a curve, which is not allowed. And you get a warning on that, end of surface. Well, that's the name of the curve. This point there is, well, it gives you a fair warning. And well, so what do I do? I just delete this one, so it will end up here. This curve now stops here. Add some other curve. That's one of the requirements for a Fairway model. And this is much in one go. With this, what does it say? Can I read it here? It's solid. Now object. And then we pick convert wireframe to solid, and wow, we have an issue again. It failed. I will show you later on. And why does it fail? This point was not correctly connected here. So you don't see such a marker here. So this point was missed. Apparently, well, that will give rise to this warning. The conversion has failed. This is a technical requirement. Euler's formula there, and it should be matched for any wireframe describing a solid. There. it gives you a warning on what to do. You don't necessarily need these, but this one is one that you should fix. How? By adding a new connection, control and select the two curves to connect with a different tolerance, because with the tolerance of 1 it had missed it already, so that will not fly. And then if you do that, then the reconstruction will succeed and you have this model, which is a good starting point for further work in Fairway. Okay, another typical problems, I've named a few, well, one you've already seen, so I can be short on this. Naked edges here, everywhere actually. This will not work. Then an overcomplete model, I select this curve and I get 3 and a polysurface in return, so there are too many items on the same position, which is a problem. And overly detailed models, yeah, well, in theory this could work, but this will give rise to so many, well, calculation time for one, but anything can be wrong in this model and you would have a big trouble finding it, because, well, even visually, all these points that will be just a big blur of error messages and whatever. So if you find this, yeah, well, what I have done in the past is use the contour command in Fairway, generate cross sections, read them into Fairway, and do the same stuff I did when importing a bias model. Only frames and start working from there. Egbert is nodding, he's done the same quite a few times in the past. And
so much of the time I don't convert it to solid, but I keep it as only lines,
yeah.
And then make a new solid, and then create your solid as close to that lines. And then it's a workaround, but that's very helpful when you have a goal.
So you can put this in the background as a separate solid or a separate object and create a new model to match these curves. You don't need all of them, you only need to have a few sections and a few waterlines, a few buttocks. If you copy those, then you're already halfway there in reconstructing this model. Okay, 5 slides to go, so I'm catching up, I think. LeanHerbs, this is the same graph you saw from Herbert, so that's easy. This is the definition of the different 4-sided patches, because a NURBS surface in theory is 4-sided. If it's 5-sided, it's a trimmed NURBS surface, or if it's more sided, or if there's a hole in it, and we don't do trimmed surfaces. We don't do complete surfaces. So you need to define this in 4-sided patches. Actually, this looks like a 3-sided patch, but that's because we have, well, define an additional point here or there along this route somewhere, so that it will be 4-sided. You can just pick a point on any of the curves, and if you do that sensibly, you'd have a nice output. Yeah?
Regarding the importation from an IGS model, what happens if you import a surface that was originally trimmed?
Then it will be, I think that's okay now, because we only import the curves in that model. So we can import a trimmed surface model.
Okay, it isn't going to take all the way the last
No.
from the original.
Good question, by the way. We don't export them, but we can import them, because we will deconstruct the actual curves in that model. But I will show you why it will not work in the next few slides, and I think that will be. This is the same graph Egbert has shown, Herbert has shown. Okay, this is how we export things. So first we make a patch here, actually a Koons patch. Look it up. It's a wonderfully simple method to construct a curved 4-sided patch, but the shape of that is defined completely by its boundaries. We don't want that because we have, well, this one is not too clear, but little arrows here show the difference between the Koons patch and the Fairway surface. Next slide will be clear. This is in a different view. So the Koons patch is the red rendered surface, and these are perpendicular offsets from this plane, from this Koons patch. So for every point, or not every point, on a subset of points of this surface, we calculate the offset here, and new U and V lines for the NURB surface are calculated automatically to give the least deviation from this new NURB surface to the Fairway surface, and that's a wonderful match, I think, within 0.1 of a mil or so, and that is yeah, is it absolutely spot on? No, it's not. But it's far beyond your production tolerances. So if you want to go further, then you're really overdoing stuff. If you cannot make it as good as we have defined it, then, well, you may stop there. And I didn't tell anybody this before, and we have had no complaints so far, so should be good. Export of models. Well, you've already seen the IGES export and opened it in Pius, but we have some more, of course. Offset to ASCII files may be handy. Some yards even use those to date. To Pius model, of course. This is really old-fashioned, but some people prefer drawing 2D still, and they want frames and waterlines and buttocks. 2D AutoCAD polyline or NURBS format, basically the same thing, but polyline rather than a NURBS format, or lines to as NURBS to IGES with options. We have the old output with the many small patches, and we have the new output with the LeNURBS patches, the bigger ones. All lines as NURBS to IGES. STL, that's actually what we use to print a model with, or you can use it in, I don't know, CFD calculations if you like. And then this is nice but outdated, so it should be in that one disused. We have some more outdated formats that we even don't know to which receiving software it belongs in some cases. Then some tips on modeling. Less is more. That's really what we see. If you're starting drafting a lines plan on paper, you don't start with 100 frame and then draw a waterline. You do 3 frames and a parallel midship section in the bow, you take 2 frames and a waterline, and you build your model up. Well, we have, I think, succeeded in mimicking the drafting on paper in Fairway. So be practical with that. Then, first things first. So what do you do first? Your contour should be one of the first things. Your deck line, a chine somewhere. The basic stuff, really, a flat side, a flat bottom, the knuckles in the right position, the tangent dependencies. I will show you that later on, but yeah, don't start manipulating your, I don't know, your anchor pocket before you have done your hull. We see people focusing on the wrong things sometimes. Yeah, first things first, and that's really up to the designer which comes first, your knuckles or your bulbous bow or whatever. But you have to have some idea of what your model would look like when you're done. Some idea, not in detail, that Fairway will do that for you, but you will have a concept in your head. Fairway will not do that for you. Fairway doesn't generate concepts. It can help you with all the rest, but not that. Beware of discontinuities. We see a lot of, I will give an example later on, but if your flat side goes straight up, then the next buttock will have a continuity problem there, because 1 millimeter in, it should either have a infinite radius, infinitely small radius, or you have a discontinuity. That's actually what we see a lot and doesn't help. Use the many features, so it will pay to, well, check it out or call us every once in a while, or be here as you are today. Then the other, read the user-friendly manual. Please do that every once in a while. Yeah, I'm not going to say the F word here. Practice a bit. If you're not sure on how a feature works, make a simple model, as you've seen me do with, to generate the developable model. Give it a go. Give it half an hour. It will pay back, really. We offer training. If you get stuck, whatever, you can call us. We can share screens. We can do that. Much of that comes with purchasing Fairway. We will train you. And after that, yeah, it may come at a price. Not every first phone call that we get will lead to an invoice. But if we're spending half a day on training you how to use Fairway, then, well, other than this, yeah. But we do offer it, so feel free to ask at least. And save your design regularly. Particularly for new users, if you start using Fairway, you start doing things that we have never thought possible or never thought would be logical to do one another, and therefore may go untested. If we find such a bug, we will do our utmost best to fix it, but in the meantime, it's wise to have the model saved just before that. So these are the tricks that are general, but after the break, I will do some demonstration on fairing, that's one, and on modeling, which comes with the same set of tools basically, but a different approach. I would invite you to write down some features you want to see in the model. So I'm going to be challenged here. I cannot accommodate 17 different shapes here, but present me with some main dimensions and, I don't know, a chine or whatever. Give me a draft of a frame and I will try explain what I'm doing to get it done in the model, and we'll see how far we come. That's basically, well, a question to you to challenge me with that. And for that I would, well, it took 6 minutes of the further session. I propose a small break here to have a glass of water and run back and forth to the toilet, because in 5 minutes I will start again. But please write down. Fixed point to plane a vessel, minimum distance to cylinder tank, hull shape based on primary hydrostatic coefficients, linears of a pipe, and can this section work? Okay. Well, I'm going to think about it while showing something else. Because I have a model prepared on fairing, because that includes a lot of the features that we have. Oh, that's nice. It doesn't exist. Browse. See. Fairing. Yeah, it does exist. I've defined a hull shape. One moment, file, preferences. I will general. So, for a bit of wasteland. I started this morning and, well, I'm new to the job, I'm the trainee here. I defined a bottom and a center line and a deck line, and then I interpolated some frames on a water line. Okay. What has happened is, by coincidence, this one intersects somewhere. It doesn't actually. That's weird. I thought it did. Well, it doesn't intersect. By interpolation, this water line did not intersect with the deck line. It went just past it, apparently. So I have now frames with a very strange silhouette here. This is not what I wanted. Okay, I can do a lot of things to start improving on that, and I will show that later. But first, this is the offending water line in my book, so I will delete that. Apply, and at least that problem is solved. Okay, I'm going to try and make things better. So here, what has happened? Well, we have some points that jointly come up with this, well, shoot over of the frame beyond the deck line. Well, if I just would press fair here, that's already gone. Now it will only run through these points. So fair means recalculate all the vertices to come up with a new solution for these points, and tangents if you have them. If I have this, I would get a little bit worried because, well, it's all over the place. So we have a nice feature for that. Objects, not that one. Bulk change of all curves. First, I'm going to delete all the internal points, so points that were leftovers from deleted curves, for instance, and I will fair all the curves. So that means every superfluous thing in this model will be gone after this one. And unify, yeah, the fairing factor I will come in a moment. So now all these little dents are gone, except for this one, of course, but that's because it's part of the shape of this model. There we go. Okay. I will select a different background color for visibility. There, let's make it a static background color, that's the one. Darker, and like so. We have a bit more contrast here. So this is the curvature of this line. Okay, I said we had mimicked basically the drafting manually. with weights and ducks? Well, the obvious thing is we can lift the weight here. So this point is ascending. If I drop the weight, it will be on its previous position, and if I raise the weight, it's there. This is not consistent, because this curve no longer runs through this point, and it should match. So that's why we have the process feature that will project this point onto the curve, and already we have a better curve there. That's part of fairing, and of course this is only based on one curve after another, which may be cumbersome. But anyway, I want to show you the tools. For those of you who haven't seen it, for some people this is of course, they have seen it 20 times before. So we can raise the weight, which makes it similar to drafting on paper. And there is a setting, yeah, that's all in right order. I can automatically fair it, and nothing much will happen because it's pretty much fair. There's a deviation of 0 between the points. That's what happens when you draft on paper. It will never be absolutely accurate, and we allow that to happen in Python. We can interpolate it. Here, if we interpolate it, it will run exactly through the points, at least with the accuracy of, 32 bits, I believe. But if you don't, then you will have a slight deviation of the points. But because this curve is pretty fair, it will be pretty much okay. If I insert a point there, and I drag it a little, new vertices are calculated, and you will see larger deviations here, because it takes more effort to run through these points. If I fair this automatically, it will recalculate the vertices, project the points onto the curve, and then you will get a new set of deviations. And if I keep that up, fairing, the line will gradually increase, and you will see here the breadth slowly move. Only the breadth, because they are connected to waterline and a frame, so the only degree of freedom you have left is the breadth. Fair. I can keep that up quite a bit. However, I can also choose what I would do in drafting on paper, is choose a stiffer spline that will not follow the points as accurately, but it will give a more fair curve. So this is 0.1 millimeter, 5, okay, I will say fair processal and switch this back to its 0.1 millimeter, and now we have a fair curve, where everything is in the right place and the deviations are 0.1 millimeter. And really that's not even the difference between afternoon and midday at a yard. I mean, temperature differences will be larger for any plate. So this is quite accurate, and it's fit for purpose.
Stiffer spline, can you do that for every spline separately?
Yeah. I can set a default value. Typically we use 0.1 millimeter, because if you take it larger, you will have some ugly effects in rendering, because you will get a twist towards the ends of plates and so on, at intersections.
Larger means less stiff.
A larger deviation means stiffer. It will not follow the points as exactly as you would. And interpolate means, as flexible as required to match the points exactly. So you can interpolate it, but we typically don't. And we are very strict in this, because otherwise people would say, even SARC cannot fair nicely using Fairway. But this, by default setting, has never given rise to any problems.
Yeah, sorry, I haven't used Fairway before, but when you talk about vertices, I understand that these are connection points with the water lines.
No, these are the vertices.
Okay. So
it's a NURBS curve.
Interpolation point.
Yeah, it's vertices for a NURBS curve, basically the attraction points for the curves, if you like. And we can play with them, but they will be overruled as soon as I drag this point in again. So they will be recalculated. So they are not the most, consistent part of this, because they will be recalculated basically with every action I do. But, good question by the way, if I delete a few, it will be very easy to make the spline a bit more fair there, and I have excellent control over the entire thing. So with a few curves, with a few vertices, I can give the general shape of a spline, and if there are sufficient points on it, if I now press fair, it will do exactly the same, but the character of the spline has hardly changed.
But you're always going to maintain the connection points in between the...
Yeah, I can play tricks with the points, I can insert them, I can drag them, and I can delete them, except for these. I cannot delete them because they are the consistency of our model. Okay, so that's...
You are in perspective view. Why would the point only go sideways or forward, aft?
Well, these will only go sideways if I drag them. They are connected to both the frame. Oh, this point not. This one is free if I would switch off this. There is a little square here in the blue color as in frame, so it will only move in the plane of a frame. This, if I insert a point there, drag, will only move in the red plane, the plane of a waterline. If I insert a point there,
Depends on the line where you are.
this is now yeah, but here this is 3D curve, so it can move everywhere, but I cannot think 3D that well that I'm capable of maneuvering my cursor and have any kind of control. So there's necessarily one direction not free, but if I press the control button, it will switch. So now I have control in the transverse plane, horizontal plane, or the longitudinal plane. So that's how, and if I press the shift button, it will go up and down. That's actually one of the tricks that I had. You can do this and, make it work. Yeah?
You choose an oblique plane, that is not the main.
Yeah, that. 3 points, I can drag these points. That's what you saw actually in the defining the line. If I press apply here, there you have an oblique plane and it's a different color. But the same applies here. It's nothing special. So if I undo that, there we go. Okay, unfairing a bit, because that was what this was about. So you have these features to fair. There we go. First the weight here and the weight there. Show me the curvature a bit. Okay. Process all and apply. Now, if I select this one and there, show curvature. Now we can see where the bumps and hollows are. So that's an option in fairing, show the curvature plots on crossing curves too. And now I have a nice view on, oh, did I switch it off again? No, I just cancelled this one. There we go. If I would now to move this point or wait, well, then this frame needs addressing. So process that point here. Well, let me start on this part. I have some freedom here in this frame. If I move this out a little bit and that in a little bit, you can see the water lines move, but nothing drastic happens there. But if I now press apply, then I've sorted this frame out and still have consistent set of water lines. And I can do the same here. Well, I will do the same, delete here, drag these ones a little bit. This one goes out and that one also goes out. Well, like so. If I move it a little bit, then I can see that my water lines become rounder going forward. Well, this one can be out, and of course this would be easier to draft. You need to find your right angles and the right settings, but this gives a pretty good idea of what I've done here. And I've done nothing complex here. I just selected the correct options and I moved these points a bit. That if you build up your network like this and you start interpolating further curves, you may, well, if I, let me give an example. By intersection, buttock. One other trick on the dragger is I can snap it to a network point. So if I want a buttock here, apply, it will run exactly through this point, which is cumbersome because we have no degree of freedom left in that point. It's fixed to a buttock, a buttock, a waterline, and a frame, so it can go nowhere. This point, it's absolutely fixed. But that leaves for me the option, well, I'm not happy with this one here, so I will drag this a little bit further, and you can see that I have this freedom because this waterline is still round. It may be ugly. You may, well, you may not agree with my intervention here, but it's, well, it's workable. It's doable. Then fair and apply. There we go. So I have this buttock now, which I don't want. Then, or I don't want this to happen because it's completely fixed as it is, running through 3 curves running through the same point. It's completely fixed. I could play a trick and I could say, well, that's beyond fairing actually, but let me do this anyway. There, it's no longer, it's now a spatial polycurve. Spatial polycurve, apply. So it's no longer a buttock and it's free again. At least for this one direction. Okay. I'm not going to make this completely fair, but you've seen me use some tools and explain on the weight and the setting for the stiffness of the spline, etc. So I think I should focus on that. Otherwise, how much time do we have?
15 minutes.
15?
15.
Oh! Let's see how far I can go.
Because after this session there will be a 15-minute break.
Yeah, I will try. Fixed point for a container. Let me first open some vessel that I already have. Well, the Rotterdam, for instance, Fairway. Yeah. Browse. The transform. This was a Rotterdam. Fairway. We don't have the explicit question there. We don't have a true answer for that. The minimum distance to a cylinder tank, but I will show you how we can do it. This is a model that we have. It's a single solid. So we'll go to Objects, Object Management. This is the target section area curve. No need to bother with that. File, Generate, and I want to do a minimal cube there. Okay, this is another minimal object. I quit this one, and there is the minimal cube. That will be renamed, will be the hold. It's active now, and there should be a small. Oh, it's not a cube. I actually done a. I will do another one. Objects, object menu there. File, generate a cube, of course. I ticked the wrong one. Cube. Quit. There's my cube. I will make that one disappear. Okay. This one inactive. So objects. Scale first. My hold will be, I don't know, 45 meters long. It will be 10 meters wide. Is that too much? We'll see. And vertical 9 meters. So I've defined a hold there, and I will now polycurves move the thing by, what is it? Oh, not the hull. This one. Objects, move the hold longitudinal by 25 meters, transfer 0 and up 1.5. Let's say that I have a really high double bottom. Apply, and now make this one. Well, I should have made it larger. The vessel is quite a bit larger than I had imagined, than I had remembered. Yeah, that's the problem with Fairway. All the vessels are this big. I mean, it's small actually. But now you have a nice reference. You can just see, well, I'm definitely in the wrong place here, because this one extends beyond what I have here. I can show that by display, rendering, base color. Yeah, let's do flat, show all shells. There we go. Yeah, this is not right. I mean, my hold is now, but you can imagine that you can just define the hold. You have the service, you can just visually check whether or not you're in the right place. And because we have the direct access to these coordinates, yeah, it's not an automatic evaluation of the distance you have here, but I have the coordinates. I can interpolate a frame on the hull and just see what happens. I can just check how far we're off. And that's, yeah, the visual feedback is, I think, easier than a numerical feedback or a distance somewhere. You can just check if you like what you see.
And Bart, in the elder user interface, you also have the option to insert, to type coordinates.
Yeah.
That you could see here. Is that still available?
It's still available, but I'd have to look it up, because once this came available, I didn't use the marker points, as they were called, but they're in the manual. If you want a set of data points just for reference, to basically do the same, but they are less visible. That's, yeah, you cannot render a single point, of course. So I prefer this one actually, but it's still there. Yeah. 10 minutes. Okay, there's one, two I have. Hull shape based on primary hydrostatic coefficients. Yeah, no, not really. We have the reverse thing. We have primary hydrostatics based on a hull form. So you saw me already change a model to meet the LCB and the what is it? The block coefficient and the main dimensions. Yeah, we have hydrostatics. One moment, I will switch this one off and check my objects, that object management. These are not buoyant, otherwise they will be included in the sectional area curve. I don't want that for this model. So if I select hydrostatic data here, we have here these coefficients. And because it's so easy to change bits and pieces, we don't have something to work towards these. But the other way around is very easy. You can just see if you're in the right ballpark.
And you can use Hillform transformation.
I've shown that in the previous one. Yeah. So the LCB is, you can do that automatically, but not the midship coefficient, for instance. You need to do that by hand, basically.
How many transformations do you have? I saw sectional area. What else? Do you have
There.
also block coefficient?
Move, scale, rotate, block coefficient, center of buoyancy, and midship. Yeah, you can change the midship section. Somebody's calling for. Yeah, should have gone. We have all the clients. We have all the clients we need right here. Okay. So that I cannot answer that any other than this. Lee nerves of a pipe. I will show you different Lee nerves, Egbert, and trust me that it will work for a pipe as well. Yeah. Whoa. Well, actually, you have seen Lee nerves. So it's just a matter of defining the right contour and send it to Linux. So why your question, if I may ask?
Pipe, when it's closed, I cannot create one surface.
No, you need two surfaces for that.
Yeah, four.
Yeah, if you want to make the ends, the end caps as well. Yeah, a circular pipe, it's not by nature impossible. Actually, it would be difficult because the Kunz patch that we start out the NURBS transformation with will have two identical sides. So there will be nothing left of your Kunz patch, basically. And defining the contour would be difficult because you have two identical curves as a boundary. So it's more like an administrative problem than a real problem. So if you need it, yeah, then divide your pipe up in multiple curves as you have already. So is that an answer enough for you? Or?
Yeah.
Okay, thank you. Then.
I do it on the right way.
You do that for the end caps of tanks?
No, for pipes, turret pipes, in vessels, or ribbon pipes, make them visible in your Fairway model.
But you could do the same then for, I think you had this question regarding the tanks, for the end heads of tanks, cargo tanks?
Well, we can define any shape for the end of cargo tanks in I don't know, a dome or whatever kind of shape you want, and then subdivide that into NURBS patches. Yes, why not? Any shape, really. As long as you can subdivide it into four-sided patches, then you can export it to NURBS. There is a restriction because the offset that I've shown you may not intersect with itself, because then you have a mess, basically. If you have a really hollow plate, then the offsets will go inward and will cross each other. You would end up with rubbish. But you will get visual feedback. I haven't shown that, but if the visual feedback looks good, basically a preview on the plate that you would have, then you're done. I will give a demo on the last question. So there's nothing there yet. A demo. Well, start with nothing. A empty model, which is advanced by this definition. Oh, quit. No, not. This is an empty model. I didn't want that. I want a basic model. Fairway. A new hull design, rectangular barge. That's what I want. Let's give it some main dimensions. 14 by 4 by 4 by 5, something like that. Okay, project name, demo, and I will try and create that frame, which should not be too much of a problem, I hope. There we are. Can this section work? Yes, it can. Polycurves, new, waterline, starting at 1, apply, close. Here we have waterline. I'm going to do this quick and dirty, I think. There, apply that one. Curve slave tangent. Otherwise, it will look uglier than I want to. start a slave tangent. Well, this is actually a bit short, but start a slave tangent. I should have done this. That's actually, I can, the curves properties here allow me to select which side becomes the master of the tangents. And that, if I would have done that before interpolating the water lines, they would have their tangents. So, but in the rush, I forgot all about that. There, curve, slave tangents, there we go. Well, I will move this out a little bit. Points, drag, otherwise it will be apply, polycurves, new. If I were to apply, close, yeah, I have two frames here, two separate frames. It's no different than what you've drawn here. I can define the knuckles in there, but a frame can consist of two separate parts. If I send this back to Pius, they will be connected, because in Pius, that's the requirement, that the frames are connected, but then you will have a connection running over center line, so there is no buoyancy connected to that part of the frame. Yeah.
Okay, well, just I wanted to study swath that had that lithium section.
Yeah.
It was connected with swaths on the forward and aft part. And yeah, my colleague that was using Python, he told me, yeah, you cannot have a frame that has two different starting
Nah,
points, let's say.
but in Pius you can actually. You only need to run it up and down here and back again. That's how you do that in Pius. In Pius it's not a construction model, it's a buoyancy model. And as long as these frames here and there have the same coordinates, there will be no buoyancy in between. So for buoyancy that's completely acceptable, and for construction or for whatever kind of graphics, you can just define two frames and insert the knuckles wherever you like. We have done a model of the Triton demonstrator, which was a trimaran, where the outriggers were actually attached, but there were three hulls, like something like this, and with a few chines up. This was the model basically, and yeah, the outliers, the outriggers were shorter than the rest of the vessel. Yeah, we can do that, but also it's very common, of course, a bulbous bow and I don't know, a rudder. How do you call that? The shaft gondola. Yeah, looking for the word. Yeah, that's all possible. There isn't really not a restriction. You can even have, if it's really separate, you would just use a second solid, as I've done for the hold, and you move that out a little bit, and yeah, that's basically it.
And it depends what you want, because you can also use a separate solid. Most of the time I use several solids for one model, only when you convert it to bias and you have different compartments in both parts, yeah, then you need one solid, but else you can use as many solids as you want.
Do they, like, if you have, for example, I don't know, let's imagine that I do that hole with three different solids. Are the three different solids are going to give me hydrostatic properties?
Yes, you can send them back as separate models. Aft and foreship you can combine into one series of cross sections, of course, if you have different models for aft and foreships, which we sometimes do. But if you have some additional buoyancy here or there, or like say a deducted buoyancy, like the bow thruster, if you define the tunnel separately, then you send it out to Fairway, to Pius, and you just deduct it from your main hull. It's yeah, that's all there. Okay, are there any further questions? Because I would end this session with Q&A. Wow. Any further questions? Did I meet the challenges, by the way? I mean, everybody happy? Oh, thank you for that. Then any further questions from your side? Or?
I think this morning you showed that there was something you can easily add a bow shape. And
yeah.
Transform all the coordinates with
correct
or something.
Correct. Let me see if I can make that work on this model. It's an ugly one, but okay, never mind. First make the model a little more consistent there. So these loose ends are, never mind about the top there. I need to study I have tried it for the bulb, and it takes a few moments, so please bear with me. First save the model as per one of my tips.
You have to auto-save, that's very easy.
Yeah, we've had issues with autosave a while back, so you didn't hear that. Here, this is the point-based. This one will go, let's say, in the middle there somewhere. It's not on center line. It's, yeah, well, it doesn't really matter. 1. Then the direction, it's now only sideways, but I want to 2. Oh, and the radius is far too large, 2. So within this area, we will get this, let's say, distortion field. This is length, width. This was width. Why doesn't it go sideways? One moment. Position there. I would expect it actually to point a little sideways. That, well, anyway, this would be sufficient for the demo, I'm pretty sure. Oh yeah, it's because it's at 1 meter. There you go. Actually, the change is mirrored, so it will be symmetrical. Otherwise, you would tear your center line away from center line, basically. But if we do this, well, this is what you'd get. So I will make a larger bulb here, and well, this is not really. I will make the radius a bit smaller there, and it should be closer to center line. And the length is a bit much. 1. And with a bit of playing, yeah, it's now closer to this point, is now closer to this point than there, so the change here will be 0.2, something like that. Apply, and I've increased my bulbous bow a bit. And with a bit of training and further studying on this method, but you can see what has happened. This frame is no longer a frame because it has moved. A part of this frame has moved forward, so it can no longer be a frame. If you want a frame there, re-interpolate it. And we are going to expand on this feature because with only this sphere, it's a bit abstract, but we want to have it more manageable, basically. You could do this several times over the entire hull. Actually, I haven't used this much, but it's more or less a preview on things to come. And it works. I mean, with a bit of doing, you can just manipulate your bulbous bow. So if you're going for a series of different bulbous bows, you can just, well, find the proper setting and play with individual settings to scale up or scale down the thing a little bit.
Has this also been released to other users, or is this only for SARC?
If you have hull-form transformation, I think you have this.
Okay.
I'm not sure. I would have to look that up.
Until last Friday, I didn't even know it was in.
No, it's mysterious things happen.
Yeah, that was the auto-programming function.
Yeah, it's, we say do feature and we get something and nobody knows what it is. Okay, any further questions? Because the drinks are waiting by now, I think. Okay, then with this I will end my presentation unless somebody else has a final question or remark. Thank you for your attention. That's it.
Thank you.